Welcome to the Funnel Reboot Podcast with your host, Glenn Schmeltzley. Let's get into today's show.
Hey, Glenn here. This is Funnel Reboot, the podcast for analytically minded marketers. There's no denying that ChatGPT and other generative AIs do amazing things. Extrapolating how far they've come in just 3 years, many can get carried away with thinking that generative AI will lead to machines reaching general or even super intelligence. We're impressed by how clever they sound, and we're tempted because of that to believe that they'll chew through problems just like the most expert of humans do. But according to many AI authorities, this isn't what's going to happen. The difference between what generative AI can do and what humans can do is actually quite stark. Everything that it gives you has to be proofed and fact-checked, and the reason why is embedded in how they work. It uses a large language model to crawl the vast repository of human writing and multimedia on the web. It gobbles them up and chops them into little sequences, like a word salad. And when you give it a prompt, it measures what words it's usually seen accompanying your words and spits back what usually comes next. The output is very impressive. So impressive that when one of these was being tested in 2022 by a Google engineer with a master's in computer science named Blake Lemoine, he became convinced he was talking with an intelligence that he characterized as being sentient. And speaking with Newsweek about it, he said, quote, "During my conversations with the chatbot, some of which I published on my blog, I came to the conclusion that the AI could be sentient due to emotions that it expressed reliably and in the right context. It wasn't just spouting words." So I don't think the rest of us can be blamed for making these leaps. But all the same, generative AI shouldn't be confused with how humans think. Take a published scientific article written by a human. How they would have started it is not by hammering their keyboard until a whole bunch of words came out. They likely started by asking a what if and building a hypothesis that makes inferences about something. And then they would have chained this together with some reasoning gotten by others, leading to experimentation, and when it's proved or disproved, they would then publish what they found about their original thought. And the output of all that is what is written in an article on the web, which generative AI ingests. So, although generative AI seems smart, you would too if you skipped all those cognitive steps that had happened prior to getting the finished work. Now, it doesn't mean that general artificial intelligence is doomed, but what we do have is more than one branch of AI to get there, and each is good at solving different kinds of problems. One branch, called Causal AI, doesn't just do the pattern thing, but it instead figures out what causes things to happen by building a model of something that it's given in the real world. That distinguishes it from generative AI, and it's what enables this type of AI to recommend decisions that can rival the smartest humans. The types of decisions that it gives can extend into business areas like marketing, making things more efficient and delivering more value and ROI. My guest is the global head of AI at Ernst & Young, having also been an analytics executive at Gartner and CSL Behring, and he graduated with an MBA from DePaul. He is the author of 5 books, and his 2024 book is about the branch of AI technology that we don't hear about very much. The name of the book is Causal Artificial Intelligence. So let's now go to Chicago to speak with its co-author, John Thompson. I'm glad to welcome back for a third time, John Thompson. How you doing, John?
Doing great, Glenn. Like I said, it's a little hot here in Chicago, but other than that, everything's fantastic.
I'm glad to hear that. And we're dealing with a hot area of artificial intelligence. Yeah, I pulled the dad joke there. We're talking not about generative AI. Can you tell us, by telling us the name of your book, what kind of AI we're talking about?
Yeah, we're talking about causal intelligence, and the book is called Causal Intelligence: The Next Step in Artificial Intelligence. And really, we wrote this book before the whole Gen AI explosion took off.
Right.
I was thinking that causal AI would be coming to us in the next 2 years, and I still think that's the case.
Mhm.
I wasn't smart enough to predict that Gen AI would jump in the middle there, though.
I think all of AI, we had been saying that it was going to be coming in the next 5 years, and we said that for a couple of decades. So, yeah, nobody's got a crystal ball here. But what we're trying to do here with the causal AI approach is it's going in a different direction that generative AI is doing, but actually it's doing something that I consider just a lot more human and something that actually is closer to intelligence, I think. It's trying to answer the question, why?
That is true. That is absolutely true. It's one of the things that, people live in the real world, which is a nice thing, and they understand causality almost naturally and natively. X causes Y. It's hot, so I'm thirsty, those kind of
Right.
things. But when you really get into causality and trying to understand and analyze and predict causality, that's a very difficult thing to do. We've been trying to do it since before Aristotle,
Hmm.
trying to define it, trying to understand it, trying to just really know what it is. And people have not been very good at it. So it's been something that's been in our mind, in and amongst us in our daily lives. We understand it naturally. We just don't understand how to analyze it and predict it very well.
But there's been a lot of work in this field, particularly among academics, and they have been using businesses. They really gravitated towards businesses to try to show how causal AI can work, while, let's say, the generative folks have been more out into the realm of fiction writers and artists. And, when we start to add in different modes, they've been adding in, music artists. Um, Tell me, why do you think something like an enterprise sized business is a really good landing place as this research is, coming to fruition? Why do you think it's going to hold such great promise for business?
Well, I think we've reached a point, an inflection point in causal AI. Judea Pearl out in USC and his colleagues have been working diligently for the last 30, 40 years in creating a completely new branch of calculus, do calculus. And there's libraries out there called do y and pi and all
Hmm.
these technologies that have been developed. So, in my opinion, the research has gone far enough. The innovation, mathematical innovation, has evolved to a more mature point. And now we have technologies that are in the marketplace and being used. There are a handful of causal AI companies out there. And I think that I'm confident in the next 2 years, we are going to have commercial grade causal AI software that are capable of being used by data scientists and business analysts.
Well, that's promising. And you also throw a bit of shade, I'm going to say, on the generative AI side, because, and this is something we've all experienced, is it does tend to show uh, the things inside of all the training data that it used, whether or not those pieces are right. So if those underlying things are biased, it's going to have that. If they are, let's say, equivocal, then, well, the generative AI is likely to hallucinate because it doesn't quite know what to make of those differing stories it's hearing. How do you say causal AI is better than that, or how can causal AI maybe help us address, or how can it complement what those problems are with generative AI? So we end up at the end of the day with something we can use.
Great question, great points. The most wonderful thing of the development or the developments that I see right now is that generative AI is going to help causal AI, and causal AI is going to help generative AI. So it's a win-win situation. One of the things that's been holding causal AI back is the lack of refined mathematics, number one, the lack of commercial software, number two, and then even bigger than those two was the fact that people in general were not very good at understanding causal pairs. So many people would say, I don't really know, what's causing the phenomena. We've seen a lot of causal work in healthcare because you really can't test drugs on people. That's unethical. So you would model it out and say, okay, I believe this is causing this. And people would try and try and try. And like any other, scientific methodology that's coming forward, there are a few people, there are a handful that are very good at it. Many people are not so good at it. The great thing is that generative AI, with all its training data, the breadth and depth of the internet and all the different subjects that are out there, generative AI has ingested all the causal information that's out there, or most of it anyway.
Yep.
So you can use generative AI to generate causal pairs. You can use those causal pairs to feed into causal AI, which then gets you moving in the right direction. So generative AI is going to help causal AI, and then causal AI through its outputs, you use the causal pairs as inputs, the final causative connections come out of causal AI, and you can feed that into generative AI. So the great news is that they're
Right.
both helping each other.
Right. And so I think to say more about how you and your co-author have articulated that they're not fighting with each other is to delve a bit further into the explanation of what causal AI is. And I'm going to start off, I'm a simplistic guy, so here's my simplistic take. Generative AI, we've been told again and again that because it's using like a neural net architecture, it's making decisions that result in those pairs you mentioned, but it's a black box that we really can't have an observable way of knowing how it got there. And we're seeing this right now with all the frustrations that marketers are having where they're watching their precious websites, which are, the thing that they were trying to get search engines to go to. And the search engines are putting up these generative AI responses, and they may be right or wrong, but what they're not doing is they're not sending traffic to the link because there's no citation when you are using a neural net to kind of arrive at something. It's the black box. On the other side, though, you get to see what you're putting into the box with causal AI, and you actually get some say into what happens inside the black box. Is that fair?
That's fair. Absolutely true. One thing that we do need to help people understand, and you've implied it, and you've been almost explicit in what you're saying, Glenn, is that generative AI is all based on neural networks, all based on neural networks. So, some people are like, oh, generative AI is just so much different than foundational AI or traditional AI or classical AI. And it's like, no, it's not. It's an evolution of neural networks. So they're virtually the same. I mean, generative AI is a subset of foundational AI. When I say foundational or classical or AI, I'm talking about predictive AI, the different techniques that we've used for nearly 50 years at this point: classification, clustering, decision trees, and neural networks. Generative AI is all in the family of neural networks. And as we know, neural networks are black boxes. So one of the great things, as we've been talking about, is that causal AI is much more transparent. You can actually diagram out what's going on. You can look at it very clearly and see what is a direct causation and what's a confounding factor, and those kind of information. The information is much more rich. Now, on the generative AI side, the great thing about it is that we're learning the value of clear, sophisticated prompting. So if you, instead of just asking a simple question like a search engine of generative AI, you build a prompt that says, I want you to think like a PhD researcher. I want you to write as if you're a 14th century poet. I want you to cite all the different sources. I want you to reason over your response and give citations of publications that you referenced. There's many things that you can do that actually stop or lessen or slow down or reduce the number of hallucinations that these models generate. People like to talk about hallucinations because it's sensationalistic and it's a failure of the model. But there's plenty of ways that you can either use causal AI or traditional AI, or and improve prompting to make sure that the models do a better job.
Yeah, I love that. And we do need to think bigger. It is the flavor du jour, but we have all of these other great things that fall under artificial intelligence, and we shouldn't ignore them. When it comes to how, let's say, lightly or heavily we need to be involved in this, you have a great ladder concept that you give us. And so we don't need to, use causal AI if it's the equivalent of a mallet and we're trying to hit a mosquito. So for like light uses, you say, well, maybe we could just use it for passive seeing. Like if we just want to understand how some different factors might be associated with each other. Maybe something simple as in healthcare, why is there a lineup in the ER? Okay, well, we can passively just see what that is. We can feed a couple of data points in, and causal AI, or even just a practical diagram, can show us that. But then you move us up into doing, so like, what if there was some intervention into it? And then we get into, and I think that one makes sense, like, what if I just opened up a new wing on the hospital and there's more supply of rooms and beds and doctors? But the next one, I think, throws a lot of us for a throw. It throws us. It's the one where we have to imagine. And this is where we have to deal with what would happen if we didn't have something. And at that point, my head kind of breaks. So can you take us through what we're trying to do when we step above association and intervention?
Yes, what we're trying to do there is we're actually trying to step into the world of causality. We're trying to look, dispassionately and objectively at the situation and say, we don't really know for sure what is the direct causal factor, but if we model it out and we use the mathematics that we have now, we use the directed acyclic graphs that we have and other tools, then we can actually step into the world of causality with a level of probability and confidence that we're going to end up with a model and a number of factors that say these are direct causes. This is not just correlation. This is not something that we think happens. You hear all the stories of, firemen and fires and
or there's more ice cream eaten in the summer and there's more pool drownings in the summer. Right. So ice cream causes drowning.
Right, exactly. All those silly correlations that we know are fun to talk about, but absurd in their nature. But we really are moving into a point of using these tools and techniques in a way that you can walk away and say, yes, we know that X causes Y, with a high degree of certainty.
But mathematically, to get there, we've got to do a flip. We've got to think about counterfactuals.
Yes.
So the example in the book, I think, is pretty good. Maybe we'll start there. So the counterfactual that was suggested when we were asking, what would make a result different? You said, well, if kangaroos didn't have tails, they would fall over backwards. Can you give us a little bit more on how exactly a counterfactual helps us?
Yeah, it was in talking about counterfactuals, it's always interesting. There's a group of people that really understand counterfactuals and love talking about them. And I think they get a little bit of pleasure out of making other people feel that they're unsettled or unknown
squirm.
About what counterfactuals are. Counterfactuals are just hypothetical situations. It's like, what if this happened or what if that happened? Like you said, what if kangaroos didn't have tails? What if, we had a fire station on every corner? What if we had, police in every building in the city? These are suppositions, is what they are. And they're really nothing more than that. So you look at something and you say, okay, well, more than likely this is not going to be the case because it's improbable or it's impractical or it would never happen for all sorts of other reasons. But I want to talk about it anyway, just to see how the model reacts and where we go from there. And you can use these extreme examples to set up polls. This is probably never going to happen for this reason. Go on the other end of the continuum and say, this is not going to happen for a different reason. And then work your way to the middle, and you'll end up with, counterfactuals that actually are probable.
Right. And the direction this will take you in, because you're trying to arrive at a model, and it can absolutely be a printed on paper model, like you've got them in the book, where you're trying to express how different variables relate to the outcome. So if I am modeling things out to be at ground truth, I think at my first pass, I will probably think of all the things that I have data lying around for. But I have to keep going, and I have to use those counterfactuals, tell me if I'm wrong, to make sure that I've also accounted for the variables. Maybe I don't even have data on them yet, but that they could have some influence that are in the root cause of the problem, or that give us a way of predicting why things are going to pan out the way they are.
That's absolutely right, Glenn. And we're starting to work on what we're talking about around. We use the terminology of agents, and we're going to take us back into generative AI for a moment.
Okay.
And we're setting up agents that we have an executing or a planning agent, and we have an executing agent, and they're models, a planning model and an executing model. Soon we'll call them agents. I kind of jumped the gun there on the terminology, but what we ask is that we ask the planning model to plan these factors out, plan these processes out, and then we give information to the executing model, and then the model actually tries to decompose these for us. And they go back and forth, and we set them up in a way that the executing model gets to the end of what it thinks is the process. Then it goes back to the planning model, and the planning model says, no, you're not done. Take this tack and do it again. So we can actually use generative AI to help us understand processes and different factors and different causal factors that we then feed into causal AI. So, in the beginning, I thought causal AI would come before generative AI, but now I've completely flipped my opinion because we're using generative AI in a way that it becomes agentic, and then it looks forward, and then models converse amongst themselves, and they take things further. Like you said, you have a set of factors that you understand and and you have data on, but you may not have an experience that brings in the entirety of causality. There may be things that are beyond your understanding or beyond your experience, but they will be in generative AI. So generative AI can actually plan that out and come back and say, here's 4 other variables or 5 variables or 2 other complete areas of operation you're not thinking of, and you need to consider them.
You've got me going so many ways here. It's funny because we haven't said this yet, but ultimately, I think everybody knows where you would want to use this if you have causal AI in your business. It's to come up with a more effective solution to whatever you're doing, to your production, to your marketing and sales. And it's hilarious to me because if you're using some of this agentic generative AI in the mix here, we're absolutely trying to make, in the academic term for it is a deterministic model, right? Here's how the world really works. But the way that we're doing it is with some probabilistic technology. And the irony of that is just hilarious to me.
Hey, Glenn, it is amazing. Once we you and I have been working in the probabilistic world for decades now, and no one really had an issue with that. As long as we were predicting and we had a high degree of confidence, no one really got into the statistics and asked us too many detailed questions about the models. Now with generative AI and that everybody's programming it with their native language like English and French and Chinese and Japanese and Hindi, and they're getting the results back, they're starting to ask questions. How is this happening and why is it giving me an answer that's patently wrong? Then we had to have the conversation like a year ago and up till today that, well, you're living in the probabilistic world. And they're like, what does that mean? And we'll say, well, it's not well versed in certain things. And, LLMs used to be bad at math. And you'd ask them, what is 1 + 1? And the answer could be Wednesday. And that really was mind bending for people. And we had to tell them, look, you are working with a probabilistic model. The model thinks that the probability of the answer of being 1 + 1 being Wednesday is a good one.
Right. It's higher than anything else it had.
That's right. So, you're not going to always get the right answer. We're no longer in a deterministic world. We're living in a probabilistic world. And I saw people just melt down every time I gave that explanation.
But if we pair these two, if we use what Causal is doing, and we actually use some of the basic diagramming functions that you talk about, we can actually see for ourselves. Like, it's so good that you talked about like humans making decisions. My word would be gut decisions, that we can actually gut check a causal model. And I really want to get into how that's going to happen. But before we do that, we're really going to take a short break.
I'll step away to address one thing that's been missing from Funnel Reboot: the ability to access the text of any show. I'm glad to finally announce that the podcast is now fully searchable and copyable thanks to the transcript feature in YouTube. Yes, YouTube. Now, if shows are audio only, they are all on YouTube. Whether you're looking for a specific episode, a topic, or want to search the full text of a show for a specific part, go on to YouTube, head to Funnel Reboot's channel. Okay, now let's get back to the show.
Okay, so John, we've got to get our head around some ways that we can model this out. And you had said at the beginning, X causes Y. So in my brain, I've got, a big whiteboard, and I've got X, and then I got an arrow pointing off of X straight to Y. So there we go. That's, I guess, the most basic cause and effect model that you can have. And that is the premise for a particular kind of diagramming that is used in this field to help us take it beyond that. And they're called DAGs. Can you tell us what the hell a DAG is?
Sure, absolutely. A directed acyclic graph is what a DAG is. And I want to make sure that we understand them before we get out the term. Directed means they only go one way. They don't recurse, they don't loop back, they only go, forward. And that's because we're trying to model the real world. And in the real world, at least the world we live in today, we don't have time bending back on itself. Time only goes forward. So since directed acyclic graphs are representing reality and time, they only go forward. So that's the directed part of it. Acyclic means that they don't recurse. They go forward in time and they don't recurse. And a diagram graph is self-explanatory. So what we're trying to do there is we're trying to draw out, okay, X causes Y. Like you said, that's the easiest relationship that we can understand. It's hot, therefore I'm thirsty. Okay, that's easy to understand. So then you can have it going forward in time, but you can have confounding factors in the middle. You can say it's hot and I'm thirsty, so I'm going to drink water, but I end up drinking salt water, which makes me more thirsty. Well, the drinking the wrong kind of water is a confounding factor.
Right. So we've got a little bit more there, and you can even chain them together. Am I right?
Exactly. Directed acyclic graphs, when most people look at them online or in books or wherever they get exposed to them, they're usually maybe 3 or 4 nodes deep. They're very simple. But once you start looking deeply into this, this chain of events, they can be 20, 30, 40, 50 nodes deep. And there can be confounding factors. There can be all sorts of things that get in the way, that branch and intermediate nodes and things like that. So, I want to make sure that our listeners really don't, go too deep into this too quickly, because, it is confusing. It's confusing for everybody, not just people who are beginners. So stick with a very simple X causes Y until you really get your head wrapped around the concepts, and then you can start bringing in the other ideas, the other confounding factors and blocking factors and things like that.
Sure. And yes, and there's a lot on that. I suppose the one thing that it's important to slow down and not glide over is that we can quickly draw an arrow between two factors, but when we have, like you said, 3 or 4, we need to be careful that we're drawing the right path, not like a spurious path. So, let's not go to the conclusion, okay, I was drinking salt water, when at the same time as you had a glass of water, you were grabbing a whole bunch of salted crackers.
Exactly. Yeah.
Could have been
Yeah.
that, right? It's not
I was
necessarily
thirsty.
this.
I drank water, and then I ate a bunch of saltines, and I made myself even more thirsty. So yeah, you can diagram that out, and it's a good example.
On that one, though, there's an important piece that we can now add, and this will, I think, appeal to most of the marketers who, let's say, are running ad campaigns, and they're looking at data sets, and they're trying to figure out, how do I optimize my marketing? Or you're a production person and you're saying, I have a machine or an assembly line that pumps out widgets, but we've got a fair number of these widgets that end up being defects, and we want to figure out why. What is it? Are the machines vibrating too much? Is there, too much bad material going in? All these things. What we can start to do is we can put weights on these various nodes. And when we start to do some really simple math, we can actually guess, until we've put it into a computer, we can guess on paper how much relative importance it might have as a factor, right?
Absolutely true. We did an analysis in traditional AI, causal. I wish we had causal. This was about 10 years ago, where we were looking at a biopharmaceutical process. And this is not where I worked in the past. I did work at a biopharmaceutical company, but this story is not from there. It was when I was at Dell. We were working with a different biopharma company, and we were getting doses or batches, not doses. We were getting batches of vaccines and different medicines coming out that had too much contaminant in it, and we were modeling it all sorts of different ways. And finally, someone came in and said, "Well, you need to consider that you've got a disposable liner inside this vessel, and it could be expressing contaminants into the mix." So we thought, oh my gosh, we hadn't even thought of that. So we put that in the model, we weighted it certain different ways. And in the analysis, we did find out that there were certain liners that were unacceptable for mixing and brewing these kind of medicines. So what we did is we went back in the process and we tested all the liners that were coming in from the supplier. And we found out that if they were above a certain level of a mix of, polymers or plastics or whatever they were made of, we rejected them because we knew that they would contaminate the batch of medicine. So we were actually doing causal analysis before we had any causal tools, but it was something that was, it was hit and miss. It was really trial and error.
So you've highlighted a very important part of this book, and I know this is something that you are always hitting the drumbeat for, because you did this in your very first book, Building Analytics Teams. You say very clearly that to move from just any model that we've sketched out and maybe fed data into to a good model, we have to involve different players. My word, not yours, but I would say you have to ruggedize the model. And to ruggedize the model, you need to have business people or like those subject matter experts you talked about in the biopharma saying, well, you've missed something like super obvious.
Yeah.
And this is harsh because especially if these are data scientists that are doing this, bringing it out into the light of day may, be very ego bruising, or maybe make them feel like their time has been wasted. But you say this is a key part of the process.
There's no doubt, Glenn, and it's, I'm glad you bring it forth in this conversation. I sometimes forget to highlight it because it's just such a part of my mindset and the way I do things. Is that if you're going in to analyze a marketing process, you need to have the marketers there. If you're going in to look at a supply chain process, you need the supply chain experts there. Just like the manufacturing example I just gave. Because we're data scientists and we understand the math, the models, the data, all that kind of stuff, but we don't understand the business operations. We did one analysis at CSL Bearing, my previous job before I was here at EY, and we showed the results, the initial results to the business people, and they said, this just can't be right. And we looked at it and said, well, how is that? That can't be the case. And they said, well, how many US states have you included? And we said, all 50. And they said, oh, well, this is illegal in 5 states.
Oh,
They said, you can't have the data from those states involved because you can't execute in those states. And we're like, oh, that would have been nice to know. So we went out and plucked those 5 states out and redid it and came back. And they were like, yeah, this looks right.
Yeah. Another way that we can, it's not necessarily about the rightness or wrongness of the model, but one way that we need to allow models to be worked in different ways, and that they can both be right, is you gave the example of a streaming service. I can't remember if it was Netflix, but let's say it was. And you said that it's eventually outputting through its recommendation engine what it's going to show different users. That it would be important to be able to anticipate the kind of user and look at this causal analysis for maybe you have one kind of user who's interested once they see a movie to look at the actor that was in that movie and to think that, okay, we might go in the direction of recommending other movies with that actor. Or you may have a situation where the movie was directed by a certain person. Well, then the recommendation engine would need to go into other movies that director has done.
That's true. And another way that we've looked at it is that, maybe people are drawn to the score. Maybe they're drawn to the music. So, you then have to go in and say, who was the person that scored the movie? Who created the soundtrack for that movie? And this can go on and on and on. Is the movie heavy? Is it dark? Is it a thriller? It's genre specific. It's pace. It's light and dark. It's thematic. There's all sorts of ways that you can take this, and I think that's part of the frustration that people have, is that there's so many ways to take these analyses that it could be endless. And some people find that frustrating. I find it exhilarating.
Well, I think you've done something right in at least terming it. So you call it, I think, causal discovery.
Mm-hmm.
And that, in other words, it's one of those, it's not the destination, it's the journey, right? So if we imagine that the model was really to give us humans with our, nearly Neanderthal brains, a better insight into how things work, then, hey, we've succeeded, right? We now see it in a different way, and that's going to spur us on to thinking about the implications, thinking about different areas that we might pursue. This can be, otherwise, and I mean, we've had examples in the past, sad to say, but they're trial and error. But if I think of, let's say, aspartame and other pharmaceutical products that have been identified for an indication which was nothing like where they started, like I believe aspartame was originally some kind of I want to say a liver. It was being developed for a treatment that would be for people with liver disease, and the lab researcher wasn't following protocol, had something, in their mouth or on the side of their mouth, took their glove, touched the sample, then touched their mouth, and it tasted sweet. Probabilistic world. There we go. We're all the way back. But causal discovery may allow, those are the adjacencies that the model could maybe open our eyes to, right?
Exactly. Yeah, that's one of the things that, as we're moving, through the generative AI, explosion and moving towards causal AI, we are going to be moving into a world, and this is the book that I'm writing right now. We're going to be moving into an era of the three families, of the three pillars of AI, and all of them are going to be working together. So, I do have some people ask me, well, when is this going to be done? When is this going to end? And I say, it's never going to end. This is the world we live in now. We're going to be building composite AI applications where we have causal to tell us what's the driving factors. We have,
right,
foundational AI to predict what we think will happen. And we have generative AI to generate the responses or the outcomes or the invitations or motivations that we want to send people to, have them do the things we want them to do. So, the level of curiosity and engagement that's going to be required is going up. It's not going to get less. So, some people are like, well, this is getting very complicated. And it's like, well, it is complicated, but it's getting easier and easier to do as an integrated composite application as well.
Yeah, and you've made a good point, just hearkening back to those software libraries that you talked about, that we have ones that, some are proprietary, but many are open source. And you can, on a laptop, start loading these things into a notebook type development environment and fire it up and away you go. The thing that we have to be aware of is that there are implications for how these causal models get used. Maybe they are trying to look at an organization and see how it could be more efficient. And we have to be cautious with how much when we feel it's ruggedized enough that we can actually put some of the findings that it has into practice. And we also have to remember that we're working inside of organizations that have politics or have issues of trust from one department to another, or maybe are sitting within a regulatory environment where there's limited movement. You highlight these things and you sound the caution, because what you don't want, and I'll just quote from here, you say, if you cannot verify how the model is working and defend the code that it has developed, it won't be able to meet the demands to explain its actions. And then you can have all those bad things like loss of trust, regulation, violations, fines, all sorts of bad things. We can't bring this out of the oven until it's fairly well baked, right?
That's true. That's true. And given that causal AI is not here yet on a broad spectrum or a wide basis, or we don't really even have that many enterprise software vendors doing causal artificial intelligence. So this is one that we're going to have to go through the maturity model. We've already done it with foundational or traditional AI. We've been doing this for 40 years now, some people 50 years. So we have to explain to people, generative AI has been with us now for coming up on 18 months or 2 years. Causal AI will be here in 2 years. So this is not something that you can just take and throw into production. We're going to be working with these and refining them and improving them and industrializing them. But at this point, we're really, testing the state of the art. And you have to be cautious, because if you represent that something is bulletproof and 100% accurate, you're on shaky ground.
True. And yet, you don't want to be caught flat-footed when you have these things that are coming and that can have the benefit of tons of great historical data. So you kind of finish the book musing about things like domain specific models with expertise in what I want to do. So if I want to start a marketing agency, well, maybe I can tap into one of these models that has had the benefit of looking at all of the factors that contribute to success. And then I plug in my own variables, and it's like running a simulation. I am able to see what I need to do now before I really invest time, money, blood, sweat, and tears, and have a better outcome with something like this. And you even take it farther to say that I wouldn't need to have the skills of a high level programmer to do this, because the way things are working, the models are actually coming towards us. Now, we'll need to supervise them, but we're actually going to, like, you have no worries about humans using these things and humans being the necessary part of the process, where, some people are saying, no, the models are going to do away with humans. You're arguing quite the contrary, right?
Yeah, thanks for bringing that up, Glenn. I always love to talk about this point. I am, bullish on humans. I think that there's going to be lots of work for us to do for the foreseeable future. You hear of Sam Altman and these other people in the Gen AI movement saying that we're going to have artificial general intelligence in 7 years or something like that. I think that's almost irresponsible to say that. My view is that we're going to have AGI, artificial general intelligence, in 2250, which is 220.
After you and I need to worry about it.
Yeah. So I don't worry about this. There's all sorts of movement in Gen AI, and there will be movement in Causal AI to build these specialty models that you just outlined. And these specialty models will need people to interpret them, to care for them, to feed them, to keep them updated. These models are not, self-sufficient. They're just models. They're just computer models. They're just code. So it's not like they get up in the morning and think of things to do. We get up in the morning and go there and say, hey, that model is drifted out of the realm of reasonability, and we need to have a new model trained and put it into production. So there's going to be lots and lots of work for people in all the flavors of AI, causal, generative, and traditional AI. So all this, I don't know. Some people say it's doom and gloom. The people in the generative AI realm say it's excitement. I think it just confuses the fact that there's going to be plenty of work for all of us.
Right. We may be, for example, setting up our day where we're going to go in and work on that model. We'll be telling our phone and having a conversation with it to structure our schedule. And then we'll maybe sit in our car and have our car drive us to, where we're going to go work with the model. So we don't have to do those things. But you're right. We're going to be using the higher functions in our brain with all that new time to figure out, well, how do things work? And I think this is one of the best things that Causal AI could provide, and why we should be looking in this direction for it, is we're human. To be human is to be curious. And we actually stand a chance of getting to know why some things are that nobody previously in humanity had even the chance of finding out, beyond maybe stumbling on the answer.
That's right. We're living in an amazing time. There's so much data out there, and so much. If you think of it this way, there's so many data sources out there that can be combined together, and you can derive new data off that combination. And then that's a first order derivative. Then if you take those derivatives and you integrate them again and derive new data, you have a second order derivative, and it goes on and on and on and on. There's no end to the amount of data that we can take and integrate in a variety of different ways, derive new data, and do new analyses. So, as long as you're curious and have the energy to do it, there's no end to what we can do.
And speaking of the ends, that's no better way to end it than that. John, if people want to get their hands on the book or reach out to you, how would you help them do that?
Well, the best way to reach me is always on LinkedIn. I'm always there posting my musings and ideas and concepts and thoughts. So John K. Thompson on LinkedIn. And then the book, Causal Artificial Intelligence, is on Amazon.
Fantastic. Thanks again, John.
Thank you, Glenn. Always a pleasure to be with you.
And until next time, get more insight into how you do your marketing so you can make it even better.
Thanks for listening. Follow the show on Twitter @FunnelReboot. If you like what you have heard today, please consider leaving a review wherever you get your podcasts.